Last video I started implementing debug symbol information and in the end got to the point where the debug line information actually works. So if I debug the executable produced by my linker, this a.exe, you can see I can single step through here and it works just fine. But on the other hand, debug symbol information does not work yet. So if I take this variable name and I paste it in here, then we can see, well, RemedyBG actually crashes. But that is because we have not implemented debug symbol information yet. And so that's the plan for today. So we want to make this one not crash, but actually display whatever initialized automatic variable is. Okay. And yeah, so how is this supposed to work? Well, we have these compilation units that we link together. Each of these simple compilation units, if I look at dumpin, headers, I guess I don't need headers. Dumpin contains one of these debug s sections, and we already had to deal with that last time. This debug s section contains a bunch of code view subsection, and the subsections, there are a couple of different types. There's the symbols, lines, string table, and file checksums. And last time we already took all of these lower three and put them into the line subsection inside of the PDB, which make the single stepping work. And so today we need to deal with the debug as symbols subsection. And I think the easiest part for now is to just look at the data that is actually in there and then go from there. Because this is a little bit more complicated what we have to do with it. We don't simply have to copy it into the PDB, which would be fairly easy, but there has to be some step in between, like we had to do for the debug type information, where we had to take all of these different debug T sections and produce one unified type information section inside the PDB. We have to do something similar here, namely there's some symbol stream, global symbol stream, I think it's called, where we have to sort of merge all of these symbol records into. But anyway, first of all, let's look at what's actually in there. And so, again, we've already sort of started this, looking at this debug symbol sections and at these code view debug subsection headers right here. So here we iterate all of the module, all of the object files. We get the symbol information out. It has a signature and then consists of a bunch of debug subsections. And well, we iterate all of the debug subsection once for all of the debug symbols, debug s symbols, and then another time for all of the line information. And here currently the only thing we do in the first iteration is say incomplete, add symbol information to the PDB. And then we do a whole bunch of stuff for the line information. But essentially what we have to do today is implement this incomplete. So let's first of all look at what is actually in these debug as symbols sections. And well, how these symbols work is similar to how the type information works. They have sort of a header, which looks like this. So it's a length field and a kind field. And then depending on what the kind field is, there's some data after it. For length bytes, though the length does not include the length field itself. And it's supposed to be padded by F3, F2, F1, which we also have to honor. Yeah. So let's see if there's also some symbol stuff. Yeah, this is sort of how it looks. There's a record length, a record type, And then it refers also to type indices, which we have to patch up because we changed those in the type information stuff. And then it has maybe some values and stuff. Okay. So let's look at all of these records. And so the way to do that is, first of all, I want to iterate over just the information inside the subsection. So I'm going to produce a substream right here. So let's call it. First of all, this is the line size. That's maybe fine. And then we read array by pointer. So we just read skip the data, I say here. So this is more or less the data. And then because size and data are sort of short names, I guess, let's call it the subsection size and the subsection data. And then we create a stream for this. So struct subsection stream subsection stream, let's call it, consists of dot data is subsection. And the size is the size. And then we don't have to worry about the outer iteration and can only iterate the substream in here. And that should be fine. So the inner iteration should look similar to the outer one then. We have some sort of while loop. Read from now the subsection stream. And yeah, sure. We need one of those headers. So I think here it was called record header, which is a little bit short for me. Is there like a symbol header, Pascal string, subsection header? Let's just make one. Struct debug code view, let's say. Can't type today. Code view debug symbol header. Code view header symbol header. Seems fine. So that button doesn't work today. No. Okay. And it has a length field and then a type field. But the length field does not include the length itself, but it includes the type, which was kind of weird. So maybe I just read out both individually because that's a little bit easier. So I have a length, and then in here I can read out a kind. So stream read, subsection stream, I want to read out the symbol length. And well, if that length is 0, then we continue. Otherwise, we read the kind. Actually, because the size is 4-byte aligned, now we don't know that each of these symbol lengths is 4-byte aligned. They should be, but they aren't, actually. That's one of the things that's in here. It's kind of weird. So we read them both individually, it's fine. So if we can't read the kind, then we just break. also call it symbol kind, I guess. So we now have the symbol length and the symbol kind. And, well, we want to print both of those and then skip the symbol for now. Kind is this. And then, do we need the length? Sure. Let's also print the length. Why not? And then we stream read by pointer, I guess, to skip the rest of the data in the stream. From the subsection stream for the symbol length. No, that includes the kind. Ugh, this is all bad. All bad. Let's make a header. And try to read the symbol header. This could be incorrect if the length field is equal to 0, but that seems very invalid anyway, so let's just not support that. And then the length is the symbol header length minus the size of the symbol header kind field. Symbol size, let's say. And then we skip this symbol size down here. And then we can simply print the symbol header. Okay, it's maybe a little bit nicer. Then I noticed this doesn't say subsection size yet, but it should. Okay, let's compile that and see what it prints. And we can see these are apparently all the symbols that are in there for compilation unit 1 and compilation unit 2. And, well, yeah. So we could print all of the kinds, but the way I'm going to do that is just to add a switch statement, and then we are going to look up what all of these kinds mean in just a sec. So in linker, no, in write_pdb, we were in write_pdb, just go back, okay, here we are. So I have all of this. Let's go record a macro. We search for .kind equal, like this. Skip it, delete everything, skip over this, and end the macro. That did not work. Why not? Search for .kind. Go here, delete, down, skip over it. Oh, I didn't set the mark probably. Beautiful. And we want to switch on the symbol kind. And then we put a default case here where it just complains. Let's just say, do we have some errors somewhere in this file? Oh. How do we complain? Like this. Just some random print. Oh, that was one. Warning. That's fine. Warning, unknown type record, symbol record. Kind blah is ignored. This might lead to incorrect symbol information in the PDB. Then we need the symbol header. Beautiful. This already exists. This already exists. This already exists. This already exists. Okay. What do you think of that? Not much. Okay, that's fairly manageable. I don't have a sort functionality, so we are doing it by hand. Is like here. Is here? No, this is here. And then all of these different constants are defined in the codeview.h. Let's look that one up. .h, no, cvinfo.h. Here it is. You come with me, kind sir. 1012 is a frame proc. One oh one. Should be here. Object name. I want to see all data. So static data. D is G data, so exported data, it calls it global. Regrel, so a value that is on the stack or something. It's usually how these work. C all the way down here. Compile 3. These are some weirder symbols. Maybe need to deal with. I mean, we should. 1147 gproc ID. Right, and these have these weird ID records which we have to patch up. It's another thing. For C, it's a build info. And for F, for S, it's the end of a function. Okay. So much for that. These are all the symbols we have to care about. And yeah, we have to do a couple of different things with them. First of all, we have to put them into the global symbol section. We have to put some of them into this local symbol sections, which we are currently filling out in here. So we are at symbol start. And on the global symbol section, the local symbol section or module symbol stream. And then there's also a global symbol index, which we may or may not have to fill in. And we also have to patch up these symbol records. So let's maybe start by patching them up by looking at exactly how each of these work. So sFrameProc, defined sFrameProc. You can see this is sFrameProc. And we care about, we need to patch up the type indices if there are any. Which in this case, I guess there aren't. So we might not have to do anything here. No type indices. Option name probably also not, no type indices. Yeah, it's just, I don't know what a signature is, but then the length prefixed name. But these, I think the L data and the G data do have a symbol index, type index right here. And I think they are the same, right? L data and G data are the same from a layout standpoint, but I think they are handled a little bit different. We'll have to see. So do we skip the symbol data? Let's just do this, I guess. U8 data symbol data, and then yeah, I'm going to say, because it's just this first the first thing after the record length and record type, which we've already extracted. So I can just say if the symbol size is smaller than 4, so the size of one of these type indices, we don't know what to do, just break. Otherwise, patch up the type index, question mark. And the type index is just at the start of the data. And then regrel. Right, everything else seems fine. This offset field is an offset in the section, right? This has a section offset encoding, so the section points to some section, and then the offset is an offset in that section. And both of these should already be correctly patched in, because that's what we did last time by applying relocations. Okay. And yeah, so let's look at sregrel. These also work like that. Oh no, never mind. They have the offset first and then a type index. So if the symbol size is smaller than 8, we break, and here we do this. Compile probably has nothing special in it. Maybe it does. These are always weird. We have an compile 3. It's just a bunch of stuff, right? Nothing interesting here. sgproc ID. These do have a type index. A bunch of stuff. So 4, 8, 12, 16, 20, 24, 28. And other than that, they are fine. Build info. Has an item ID. Oh. I'm not sure, like this gproc, did we look at the correct thing? gproc 32 ID. Yeah, so these are the same. gproc 32 and gproc 32 ID, and this is a type index or ID. But we have because we have an ID thing, this is not a type index, but an ID index. I guess. Because I think that we have to do some weird remapping here for no clear reason, but that's fine. Maybe we'll just ignore it for now. Build info was fine, right? No, that had an item ID, right? And then sproc ID end, I know is just nothing. Pretty sure, yeah. It's one of these end symbols which just has an end and nothing in there. Okay. Now, there isn't really yet a good resource in my documentation of how I should process all of these different symbols and where they go. I want to add that after I've actually done it. And so currently the best thing in my documentation to figure out where all of these different symbols have to go is to look at the symbol record stream, because it talks very slightly about it. And so this is the global symbol record stream. So all of the symbol records should be in here that are like global. And then there's also for each module a module symbol record stream. Okay. So the symbol record stream contains code view symbols, which reference symbols in the module symbol streams for all modules, as well as spub32 symbols, which we won't care about today. Its stream index can be found in the DBI stream, sure. It contains no header and thus immediately starts with the first code view symbol record. Code view symbol records start out with a 4-byte header. This is exactly what I have in here. All symbol records in this symbol record stream are produced by link.exe/mspdbcore, which is what we are doing right now. We are cosplaying, role-playing MSPDB-core, and are based on the symbols provided by the compiler in the object files, sure. The symbol record stream contains one sprograph, one lprograph for every procedure, a sg data or sl data for global declarations, and a s constant for every named constant, enum or const expression, and a sudt for every type def. The slprograph and sl data 32 reference static declarations, while the other symbols reference exported ones, so the G versions of these. And for s constant and sudt, there's only ever one symbol for a given name. For example, if there's one compilation unit which has my type and my constant, and in another compilation unit they are of different types, then only one of the my constants and my types are referenced in the symbol record stream, and the other one is contained in the module symbol stream, which it declares it. And the code which produces these symbol records can be found here, which is sort of something I want to look at while doing this. And as data ref is also defined but never used. And then there's one warning here, is that these reference things use one-base module indices for whatever reason. And the other thing we have to do is to actually figure out if the record which we are interested, the symbol record we are interested, is already in the symbol record stream. We can use the global symbol index stream. But I hope that today I can just skip that and do that next time. So in fprocess sims, let's maybe make this big. Yeah, so it iterates over all of the symbols. If you can't read this really well, it's because it's written horribly. I can't fix that. Iterates over all of the symbols, gets the end of the symbol. It goes over the record type, which is currently what I do, sort of. Then there's a case for each of the record types and does something to it. Namely, for procedures, which are all of these, it packs a type, it copies the symbol out to the module symbol stream, and then it packs a ref to GS, which what this is doing is it puts the symbol or a reference symbol into the symbol record stream. And then packs a reference to that symbol in the symbol record stream into the GS stream, so the global symbol index stream. So let's do that one first. For all of the procedures, which we have this gproc ID, not a gproc. And for a gproc ID, it puts it to the gproc and says fconverted equals true. And then this is the code, but that's the same. Convert ID to type, which we have to do. One is convert ID to type. Then 2 is pack ref to GS. Do. This is what we do maybe next time. 3 is, I guess we will do the put a reference symbol. Pack ref to GS. Sure, let's just leave it like that. And then copy out the symbol. and add a global reference. This is also something we won't do today. So the ID index. We have, and for these IDF indices, we before in here sort of fix them up. We already had to convert them because we were putting them from the debug type sections inside the object file into a global debug TPI stream, so the type information stream inside the PDB. So we have to first of all fix that up, and so we need a similar thing to this remap type index that we do here. And the remap type index works by taking the object file type index to PDB file type index map. This map I currently just have lying around inside this loop, but I need to extract it into something, some information. I don't think I have anything like that yet, so let's just make one. So I need one for all of the object files, so this is going to be U32. Maybe we also need a size. Let's make a struct out of it. Size T. Where we want this. Size T is size, and then U32. Let's call it type index map, or let's call it data here and say this is the type index map per compilation unit. And type index map, we allocate push data into the arena. It's not push data, it's push array here. Into arena of one of these type index maps. How many do we need? We need amount of compilation units, I think it's called. That many we need. Let's see if that's correct. Write PDB information, amount of object files. It's also okay. Per, and let's not call it compilation unit, but per object file. And then we take the thing, data is this object file, whatever, blah thing. Sometimes do go variables with these names, don't I? And in the end, we now know how many are there. Which I feel like I have that variable. It's called object file type index. But I guess I can compute it, and that's a little bit better. So you come with me. Size is where we currently are in the end, minus the start. Okay. Now we can use these maps down here. Maybe I make a define again like I did above. Remap type index is fine, and I guess I undefine it here. And so, what do I want to do? I take some type index, I assign it to, if it's smaller than OX1000, it just becomes itself. Otherwise, if it's bigger than object file type index, so this is now the size. So this guy. And let's maybe get these out here. Type index map size is this. Then U32 star is type index map data. Beautiful. So then we have the type index map size. If it's bigger or equal to that size, we just say it's 0. We don't know what it is. It's fine. Some invalid file. Otherwise, we take the type index map data. We put in the value of the type index and subtract OX1000 to get the type index inside the inside the PDB. And that is sort of fine. But, well, first of all, for remapping, this is sort of fine. So for these guys, where we only have to remap, I can just take this now and say type index. And also remap this type index. And remap this type index. And that also works for ID indices, so this should also be fine. Just converting always the local one from inside the object file to the one from the PDB. But here we now have to check, have to convert this ID index to a type index using probably the record associated to this ID, which is a little bit annoying. Let's see what they do, I guess. Convert ID to type. This is always so unreadable. P-type. And they get a P-type, which I'm not sure if that means it's already not an ID. Ugh. Okay, so this ID index is probably pointing to an LF func ID. So yeah, at this point this is, even though it says type, it's an ID record, and it checks that this ID record is an LF func ID. And yeah, then this LF func ID has a type index, which it's using to patch it up, right? Yeah, so this is how they look. So we now have an ID index, which we patch up first of all to be remapped. So remap the ID to be referencing the ID stream, the API stream. Now we want to look up the record associated to the ID, which this is going to be a little bit annoying. But I think it's some sort of binary search over some information which we put out, or this index offset buffer. Do we know where that is? Well, I think we could figure it out. I think this is the only case where we care about this, so. Wait, type index map, no, that's what I just filled out. We also don't really have the header right now. We have a hash table which does the opposite of what we want. But it's also kind of local here. Ugh. Do I really have to pull out all of this stuff just to get the index offset buffer of the API stream? Could just be really piggy right now. Iterate the whole TPI stream, but that's not easier. Not that much easier in any case. Could allocate extra data, but that's also kind of annoying. Let's just suck it up. And bring this one out. And say index offset buffer. We also kind of need the size. We only need the IPI right now, so IPI index offset buffer, which then starts out at this, and we say the IPI index offset buffer size we have to calculate in the end. Let's initialize them for now. And this is later on where we have the size. We have the byte size of it, I'm pretty sure. Yeah. Index offset buffer length. Is this length divided by the size of one of these entries. Okay. And then we can binary search that. Which means we have to make another function. So we have to find where we were. Okay, I'm being really slow right now, sorry. Okay, we were here. We remapped the type index. bsearch. How do we call bsearch again? We give it a key. Index offset buffer entry. Is this how it works? And we have the ID index. We have a pointer and a count. Key, pointer, count, size, and a comparison function. We have the key, then the IPI index offset buffer. The count is this size. The size is the size of one of these boys. And the comparison function. Compare index offset buffer entries by index. And this function returns an int and takes const void star. I can ignore the const a void B. For local functions, I still have to put a semicolon. And then we have a struct index offset buffer entry, A entry is A, and the B entry is B. I guess. And then if, oh, I see. The key can be whatever. And, right? Comp. The comparison function which returns a negative value if the first argument is less than the second. Key is passed as the first argument. An element from the array as the second. But it says key is passed as the first argument. So I don't need to do this crap. Entry is element, and then the key is simply a U32. And it's the ID index element. And then if entry type index or return returns a negative integer if the first argument is less. So the ID index, this is less, then -1. So this returns negative if it's minus this one smaller. So this should be correct, hopefully. Okay, and then we can simply pass the D index here, the index offset buffer, the size of the index offset buffer, the size of one of the elements, and then this function. And then let's not call it compare, but okay, so far so good. And that should give us a pointer, or like should give us one of these index offset buffer entries when it exists. And well, does that help us that much? I mean, it does. It speeds it up. It's not going too well. But anyway, let's fight through it. Index offset buffer contains, the first offset is 0, I think. Yeah. Which means this, I have to add the size of the header to get a pointer into the TPI stream. Ugh. Sure. index of set buffer entry is this. If we didn't get one of those entries, we break, I guess. And the entry offset missing the TPI, but that's fine. Offset in record data plus the size of struct TPI stream header. This gives us the U32 or size T, I guess. Offset in TPI stream struct where do we define type record header? Sure. Type record header is in the TPI stream .data.base, I think, maybe, plus the offset for to type index starts out at the type index of the entry type index plus while the type index is smaller than the type index we're actually looking for. Then we want to skip this type record header. So type record header is void star of U8 star of the type record header plus type record header length plus size of a U32, U16, which is the same as the type record header length. This should mean we now have a type record header, which should be one of those elfunc IDs. And we need to make sure of one thing, namely this ID index could be less than OX1000. Otherwise, all of this should be valid because we know that the ID index is valid. Otherwise, all of this should work. Hopefully. Kind is lfunc ID, which an lfunc ID is not in here. All right, it's the wrong file. One of these. This guy. Sure, there are a bunch of breaks in here, so can add more and speed this up a bit by saying if it's not this, we break chaos. And if it is the size or the length is not enough to keep in everything in the func ID, and we also have a problem. Right. What happened? So we do have to have these 2 bytes in mind, but then it is 4, 8, so 10 bytes. If it's smaller than 10. We break. Otherwise, U32 type index is the type record header +1, I guess. Cast it to a U8 +6. Cast it to a U32. And then we can finally patch up the ID index to be the type index. There's like no way all of this worked, but we'll see. And so we now have patched up the ID index, and the last thing we have to do is we have to patch up the symbol type, because it's not a gproc ID anymore, but now a gproc. And it's not an LF, but an S. Okay. Maybe none of that was really necessary, but now we have implemented it hopefully correctly. And we can go on to the next ones. But yeah, so that's what they do, right? They get the type index, which is all of this gunk. And then if it's a func ID, they get out they cast it to a func ID and get out the type index. That's what we do here. then they just return that. I want to go back to process sims. We were looking at this guy, where we first convert, then we pack out a ref. And then here I say incomplete, ref care about GS, but here we have to pack a reference symbol to the symbol record string. And what are these references? Well, they come in the form of s ref something. What did I say? G. In my documentation, I talked about this. We read this. An alprograph or sgprograph. And I think it's not gprograph, but just prograph for whatever reason. Yeah, this thing. Reference to a procedure. So for this, well, first of all, we need a symbol record stream. Streams. Amount of streams. Which means we also have to patch up this guy to include the symbol record stream. Okay. I copied this, but then didn't do anything with it. Symbol record stream. Where do I want to put this? Oh, maybe here. And into the symbol record stream, we now allocate the ref symbol. Code view proc ref sim, I guess. Because that's what they call it. Reference symbol. Is push struct into the symbol record stream, one of these code views reference symbols. Then what do they contain? They have a record length, a record type. Which I could just make into a header. I think I like that. Which is one of these code view symbol headers. A sum name with this, which is a SUC of the name, which I think is always 0. An offset in the actual symbol stream. So this is what we are currently have. So offset in symbol module symbol stream. A U16 module index. And a U16 alignment. header, I think it's length, kind and length. Kind is, oh, I took the wrong one. Is it the same? Please be the same. Oh no, it's the name afterward. Which makes this whole thing a little bit annoying because it means it's not aligned. So we have to call this push struct manually and figure out the length of the name. Where do we have the name? I guess from the gproc32 ID we need the name. Okay. But let's not care about the name right now. Let's not care about the allocation and just fill it out. So the kind is one of these S paragraphs. We also have to look up the length, like the length of the one of these guys, I guess. -2. I guess I just call it symbol reference length. Reference symbol length. Reference symbol length. Reference symbol length. The type we have, which is the kind, is sum of name is 0. As the offset. Offset in module symbol stream is where we are currently in the symbol stream, which we can figure out by looking at the where we currently are in the module symbol stream minus the base, which is the symbol start. But I can also just take the base. Current minus base. We offset the module index. The module index should just be the compilation unit which we are currently dealing with, so the object file index. And then the name. So the reference, so let's get the name first. The name we are supposed to get, I guess, from this sgproc ID thing. Which is a proxim32, which needs size of all of this gunk. But we just figured out that the type index is at 24 plus 4, 28, 32, 36, 30, no, not 36, 24, 28, plus 4 is 32, plus 2 is 34, 35, I think this is 1 byte long. Yes. 35 and then the name. And so we can get the name. Is the symbol data plus 35, and then symbol name length is stern comp stern then of the symbol name with the symbol size minus 35. If this is size t, if the symbol length plus 35 is the symbol size, then we break. So this is the case if it's not zero terminated for whatever reason. Okay. Otherwise I have the symbol name and the symbol name length. So I can calculate the reference symbol length to be size of this guy. Do I have an offset in type? Yes, I do. Of one of these, and I want the name field, so the offset of the name field plus the name length. And then we need to align that. Do I not know my buttons anymore? What's happening? And not 3? Okay. I don't know my buttons anymore, apparently. And this guy needs to be arena. I think it's just arena allocate. Memory allocate bytes into the symbol record of reference symbol length, and alignment we don't care. Then we need to know what a proc ref is. It's apparently this guy. And finally we can memcopy into the name the symbol name. And I forgot the zero terminator in this calculation. Okay. So far so good. We have copied out the reference symbol. Which was step 2. Copy out the symbol. Should copy out is 1. Add a global reference. Should add global reference is 1. Beautiful. This second one might need to be an offset in the end, but I won't care about global references right now. So that is fixing up all of the records done. Now, let's look at all of the things we have that we need to do. So this first one was the procedure, which we're finally done with. sBlock is with as whatever. They copy out the symbol, but we don't have them yet. There's an enter level, which is sort of interesting. Do we have an enter level after the proc? Yes. So we need to keep track of the level, I think. Size D level. And that's S64. Not sure. So all of these enter level and copy out the symbol, but we don't have any of them that yet. So who cares? Manage procedures, we don't have. Constants, we currently don't have. UDTs, we don't have. But we do have an LData32, I'm pretty sure. Yes, LData32. We pack the type, which we always do, so that's not anything interesting. We copy out the type. So should copy out. Here's 1. And then if the level is 0, we check whether or not this thing has a name. Copy it to the symbol record stream. And add a global ref. But I think in this case, because these sData32 things right here, they simply are an offset, a segment, and a type index. I forgot what I was going to say. Yeah, I think we just copy the structure and put it into the thing. We don't have to make a proc symbol. I think is what I was trying to say. Should copy this one out. I guess. So we want to check out if it has a name. symbol size 2, 6, 10, 12. We have a name length. Then we want to copy this one to the global symbol stream. Yeah, and I guess I'm going to do that here, even though we might have to do that in many cases, because I need the name, I think. Well, we can think about the structure later. So for now, I'm simply going to do push array into the module symbol stream of the symbol size of U8s symbol. I'm just going to mem copy into this for symbol size and from symbol data. Then we still need the header, so push struct into the module symbol stream, not the module symbol stream. Oh, that was close. The symbol record stream. Of one of those code view symbol header thingies. And I here is the symbol. I don't need to deref the symbol header. Okay. That was for an L data entry. For a GED data entry, we just always copy to GS. Pack type, pack global, copy global reference. Should, that's the thing, should add global reference. And this gdata thing needs to care about the name later on as well. But for now on, we don't care. And so these don't get copied out. For the L data, they do get copied out. F copies them out. Which sort of makes sense. You only need them in one space, the global ones, because, yeah, you only need them in one spot, and because they can't be, because they're global, there can't be multiple of one name. These are global, hence they don't need a name. Don't need to be copied out. Inline sites we don't have. As proc ID end, we had that one, and that one needs to get patched up apparently, so we need to say record symbol header dot record type, record kind, so just the kind is now an send, which is 6. I'm pretty sure. And then we need to copy that one out. Yeah, copy symbol out. Exit level is also important. Same is true for send and inline side end, but whatever. Okay, object name. Don't think I care about this for now. Compile 2, compile 3. Copy symbol out. Then it saves some stuff, which I don't know exactly what these are, but that's fine. Env block we don't have, annotation we don't have. And then in the default case we pack type copy symbol out. Now we assume we don't have a default case. Okay, did we deal with all of them? No, we didn't. Which I guess we have to. So I think I might turn this copy symbol out around and say, yeah, let's say this is copy symbol. Just copied it. Why don't I use that? Should copy out. I call skip copy out. All of these didn't have any special handling. So now I'm wondering if I should make a default case. Okay, let's keep him for now, just right here. And so this is the only one. where we had the skip. So skip, copy out. Right? Let's go through it once more. These ones we copy out. 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 This one 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 we don't, but that's the gdata case. These ones we copy out. Right here. UDTs are going to be a thing. And constants are going to be a thing. But I don't care about them right now. These ones I copy out. These ones I copy out. These ones I copy out. And these ones I copy out, and that's all of them. So this one's the only one that we skip. What's your problem? Is it the other way around? Swear to God, I can never remember. Type index map. Type index map entry. Should copy out. Gone. Invalid reference on ID index because this is also called ID index. Offset type undeclared. Sure, I have it somewhere, that's good enough for me. Go to 1. Copy out. Copy out. Okay, and we also have to copy out. If not skip copy out. We do essentially the same thing what we did for the symbol record stream, but for the module symbol stream. Okay. Warning. Sure. Declaration hides previous declaration. Here's the previous declaration. Assume this means I copied this here and for reference or something. It's only red. String table size. Why is the string table size And if you check this, that's probably why it's never read. That's fine for now. Okay, if this whole disaster worked, then test shouldn't crash. Didn't crash. And the PDB which we produced should have some information. So validate for the a.pdb dump. Error. The symbol information size in the modules is not 4-byte aligned. The symbol information size for module compilation unit 1 is not 4-byte aligned. But what's the size? Do you see that? 2E. How can that happen? When I was dumping this, yes, maybe. No, this one is subtracting the header completely. So that shouldn't be a problem. And then we add a header and the symbol size. Symbol information size for module compilation unit 1 is not 4-byte aligned because it is 12E. Right, PDB. Print symbol size. Okay. How? How is it 4C after the first one? 3D. Something is going very wrong. Get a code header and then the symbol size. Oh, it's just taking the wrong symbol size. No, it shouldn't be. Let's see. That was an issue. No, it's still screwed up. That's good. So let's also print the symbol size. Why is it printing that one not as X? Because it's not... because it's an int or something. B. Sure. B, C, D. Wait, is D unaligned? These are unaligned somehow. So I guess let's look at copy out. If this aligns it somehow. CB for sim. Append, psim, CB for sim. I need to align this. It'd be weird. Ugh, I'm not signed in here. That's not what I wanted. Searching for this guy. Doesn't tell me anything. Okay. But this is definitely unaligned. Like it says 7. So I guess I align them. Seems so weird. But the next one is correct. So let's say alignment. Says T, I guess. U16 alignment is symbol header dot length. I guess it needs to be an int, otherwise it complains. +3 and not 3 minus symbol header length. And then the symbol header length plus equals the alignment. The alignment we push array. Then F3, F2, do I check and the validation utility alignment. It happens a lot. F0 plus is for u32 index equals 0, index smaller alignment, index plus plus. We have that the alignment of index is OXF0 plus alignment minus index. Okay. Alignment. Oh. Adding. Okay. Error length, Klammern, parentheses 40, off, symbol 0, offset 4, off, compilation unit 1. As invented, yeah, okay, we expect that the symbol length mod 2 is because of the kind field that I had to do that. Now it's not complaining anymore. Did it dump anything? It did dump some symbols. And this is from compilation unit 2 with these symbols. For compilation unit 1, we have these symbols. And then I care about the symbol record stream, I guess. The records, which maybe this validation, oh yeah, the symbol record stream doesn't print anything. But it might require a public symbol stream for some reason. No, or it just doesn't print anything. It should be printing something if it finds a pub32. Or a prograph. So something's going wrong. Let's print the size again. Oh, I know what's going wrong. In write PDB, we forgot to add the symbol record string. In two places, actually. So first of all, we have to apply the data. So somewhere here, get your favorite one. That was the worst one. Why is the favorite the worst? Symbol record, we want the memory arena for the symbol record stream, and then the size, it's the size of the symbol record stream. And then we also need to assign the value inside of the DBI stream. So here in the DBI stream header, I currently set the stream index of the symbol record stream to -1. Now we want to apply this value. The size, whatever, of the symbol record stream has invalid alignment. So I guess there I have to do the same thing. I will dig through the sources if I'm just doing something wrong, or if it's actually the case that this is how it works. Because that seems weird to me. But for now, let's just grind through it by wherever we put something into the symbol index stream, so module symbol record stream. Here, we also have to do the alignment thing. So let's get this boy, I guess. I guess let's do a copy to GS. If symbol for JS, this also sucks. Alright, copying it, not caring. You come with me, kind sir. So the alignment, which I guess we can calculate up front because it's always going to be the same. Maybe, maybe not. Okay, let's say it's not the same because it's not the same for the ref symbol. These we already have. And the padding, everything goes into the symbol record stream this time. I guess if we align it once right here, then the alignment down there later on shouldn't do anything. Okay. But that's, I think, everything I had to do. So we can do the same thing here. Okay. Symbol information size is not provided aligned. The symbol information size. Wait, what did I write now? That worked. Okay, so let's redo this, I guess. We want padding in the symbol record stream. Fine. We calculate the alignment. By doing something like this. Here we do patch up the symbol header alignment, the length. Would guess that this doesn't do anything if I do it twice. It shouldn't, right? I subtract the length 2, add 3 and not 3. It should align it up after subtracting 2. Here it definitely didn't do anything. But here it might, I guess. Sure. Let's see if it does. What's the issue? Symbol 0 in the symbol record stream has invalid length. Okay. Fair enough. Now I want to get rid of this as tag. Does that still work? No. I think I know why I need the heck, because otherwise I don't copy out the alignment there. Okay. So this works, right? Now symbol 0 has invalid length, and this is one of these gproc ID symbols, I assume. Which here I probably calculated the length incorrectly. Because when I assign the length here, I must subtract size of the reference symbol, header, length field. Right, because the length doesn't count itself. The sprockgraph start. Symbol index 0, offset 0. Symbol in the symbol record stream has invalid module ID 0. Amount of modules is 3. These module IDs are 1 based. These module IDs are 1 based for some reason. Symbol 1, we got one symbol done. Offset 18, and the symbol record stream has invalid length 28. So this could be multiple things. Either I screwed up some of these padding things, or it's because I also need padding down here. Wait, don't I already align these lengths? I already aligned these lengths here. I don't fill in the padding, but that should be fine. So it would be nice to know what kind of symbol this is. Symbol 1. So to do that, it's invalid length. So what I want to know from my validation utility, yes, include, okay. So what is the kind of this thing? Because I know the kind. And I guess also want to do it here then. HLC validate.c. Kind this 11OC. And this is why. What do we want? Test. Then we want to do validate. All right. Those are all the symbols we put in there. Beautiful. I don't think this means remedy is going to work, but we could check. Might. No identifier not found. Because I think we need the GS stream probably for these to work. But these are in here now in the symbol record stream. And they're also probably here. Because I'm pretty sure I check something. Invalidate for a not data ref. One of these. I read the name. Oh no, I don't check anything very special. I thought I might check that the... No, I can't even check that. They don't reference anything, only the... Only these ones reference something, so the procref, but we can't do that here because they might not be valid. They're only valid if they're referenced by the global stream, whatever, by the global symbol index. Okay. Yeah, so sadly, I didn't get it to work, but we are one step closer, I guess. We can now fill in some part the symbol, the symbol record stream and the symbol module symbol stream for all of these different entries. I think, because this was sort of annoying and nothing else, think I'll do all of the other symbol records of stream, of video, of record, whatever. And then next time we probably look at the global symbol index. Until then.